Let us determine all the positive integer x such that 8 to the power x plus 2 to the power x equal to 130. Observe that we have first of all 8 to the power x plus 2 to the power x equal to 130. Now we know that 8 equal to 2 cube. Let's write it that 2 cube to the power x plus 2 to the power x equal to 130. Now we know that 2 to the power a whole thing to the power b equal to 2 to the power ab. Let's do same thing here. So 2 to the power 3x plus 2 to the power x equal to 130. Now 2 to the power 3x once again can be written as 2 to the power x whole thing cube by the same law, plus 2 to the power x equal to 130. We got something like y cube plus y equal to 130. So let 2 to the power x equal to y. Now we solve for the equation y. When I write 2 to the power x equal to y, then I obtain y cube plus y equal to 130. That can be written as y cube plus y minus 130 equal to 0. Observe that y equal to 1 is not a solution of this equation. Neither is it that 2. 2 cube is just 8. 8 plus 2 is 10, but we want 130. Neither is it that 3 is a solution, but y equal to 5 is a solution. If y equal to 5 is a solution of a polynomial y cube plus y minus 130, then we know that y minus 5 is a factor of the same polynomial y cube plus y minus 130. If x equal to a is a solution of the polynomial fx equal to 0, then x minus a is a factor of the polynomial fx. So we apply that result and we want to factorize it. Since we know that y equal to 5 is a factor, so we just write y cube as it is minus 5 into y square. You see that we can take y minus 5 as a factor. But when I write minus 5 into y square, I have to adjust it, make it equal. So we just add 5 into y square. They are equal, yes. Again, we want y minus 5 as a factor. So we write minus 5 into 5 is 25. 25 into y. So you'll get once again y minus 5 as a factor here. But when I write minus 25y, I want it plus y, so I have to write plus 26y minus 130 as it is equal to 0. You can see lastly that y minus 5 is a factor here as well. So we take y minus 5 common. When I take y minus 5 common from here, I'm left out with y square. I'm left out with 5y and 26. Now you know that if product of two numbers is 0, then one of them has to be 0. Maybe both are 0, but we don't know which one is 0. Maybe y minus 5 equal to 0 or this is 0. So we assume, we consider first case, y minus 5 equal to 0. One of them has to be 0. So y minus 5 equal to 0 or y square plus 5y plus 26 equal to 0. If y minus 5 equal to 0, then y equal to 5. If y square plus 5y plus 26 equal to 0, then this is something like quadratic equation. Ax square plus bx plus c equal to 0. Roots are given by x equal to minus b plus minus root over b square minus 4ac by 2a. So y equal to minus 5 plus minus root over 5 square minus 4 into 26 into 1 by 2 into 1. That's equal to minus 5 plus minus root over 25 minus something that is bigger than 25 by 2. Observe that this quantity is not a real number. Not a real number. Now lastly, we have only one choice if we are dealing with real number only, y equal to 5. But we have started with something like 2 to the power x equal to y. We have assumed 2 to the power x equal to y. So 5 equal to 2 to the power x. If we take log with base 2 on both sides, then we get log of 5 with base 2 equal to x. So the question says find all positive integer x. The answer is there is no such positive integer, but we have a real number x. X equal to log of 5 with base 2 is a solution. Is a solution in R in the set of real number, and if we are asked find the integer solution, then our answer is no integer solution.